Hi, welcome everyone. We're going to go ahead and do a demo here of how to use RapidPipeline inside Blender. And this is specifically about CAD workflows. How do you process CAD models such that you want to use them for rendering and for other purposes? Typically, they're not that well formed for rendering use, but we have a whole set of great tools here that lets you basically operate on CAD models and optimize and do all kinds of great things in order to get them ready for not just rendering, but also for real-time use and on the web and in augmented reality and other things. And it basically just saves you a ton of time. So we're going to dive in and show you how it works directly in Blender. A bit about me. I'm a senior 3D technical artist here at DTG. I've been here about 3 years, and I help customers kind of figure out how to use this great technology and how best to apply it to their particular situations. And I also do documentation and tutorials and webinars like this. And let's see, before that, I was 6 years at Wayfair leading the 3D team there, doing rendering of e-commerce products and also converting to real time and material standards and automated rendering and all kinds of things. And let's see, 20 years before that, I was a game artist for 20 years, working in game development, doing art direction and technical art and all those kinds of things. So a lot of experience with rendering and real time. And today, yeah, I said we're going to be looking at RapidPipeline and how it integrates into Blender. And you can use RapidPipeline on its own, but when paired with Blender, you basically have this great front end that lets you do all kinds of manipulation of your model and integrate it directly into the whole Blender interface. And so it just gives you that extra layer of control for your 3D models. So we're talking about how RapidPipeline extends that with CAD specific behaviors, dealing with all the things that you need to do when you do with CAD import and things that you need to fix, basically, because CAD assets are made for manufacturing. They're not made for rendering, really. So we'll talk through all those things. And I want to talk a little bit about RapidPipeline. What is this thing? It's basically this tool set that we have that's really well formed and basically lets you do all kinds of operations on 3D models. And specifically with CAD assets, you often have, say, invisible geometry inside or surfaces inside the model that you probably don't want, like on the microwave there with the input model. And you look at the wireframe, there's engine parts inside of there that are necessary for manufacturing to have that data, but you don't really want that in your render model because it's, first of all, it's hidden. So it's not being rendered anyway, and it's just extra weight for the model. But also, when you're going downstream pipelines, you don't want to share your manufacturing know-how with other clients and your real-time models and all those things. So it's best just to call that out. And we have a lot of automated routines that automatically pull out that data. But it's also smart, like it knows when you have surfaces with transparency, like the glass front on the microwave, that you probably want to preserve the things that are inside behind the glass and not to cull those things that could be seen through those transparent surfaces. So you can choose whether you want to keep the pizza inside the oven or whether you want to cull it. It's up to you. You could say, hey, just ignore transparent meshes and treat them as opaque and cull everything that's not seen. And you have a variance for how much things can be seen before they're culled. So if you have things penetrating slightly or seen through gaps underneath different parts, you can kind of control that and say, how aggressive do I want to do my culling? And then we have a whole materials pipeline as well with Twin Studio on the left there that lets you bring in CAD models and do all kinds of processing directly on the models and nice drag and drop for materials and rendering and things. But today we'll be talking about Blender and how that works. I also wanted to talk about how RapidPipeline works on the back end. It's basically this executable engine that runs behind these different applications. And we've built front ends that work inside of 3ds Max and Maya, Blender, Unreal, and Substance Painter, and now Twin Studio. But they basically all talk back to the engine running behind it. And they send that data from the application depending on what format works best for that application. So for Max and Maya, FBX is the best choice because it lets you get that rich material model out. And for Blender, it has a really good GLTF runtime for handling that data. So that's how we send data out to process it and bring it back in. And the same with Unreal and Substance. And that's just how it works. So let's jump into Blender and see how that works. Go to the desktop here. I'll launch Blender. And basically we support, I think, from Blender 4 dot something up to the latest. I think it's Blender 4. It's on the website. So let's go look at that for a second. See, we have the website here and our help files. If we go in there and look at Blender, I think, let's see. Yeah, Blender 4 and later. So that we support all the latest versions of Blender, which is great. This is Blender 5.0.1. So I'm just going to delete the default things that are in here. And RapidPipeline comes in as a toolbar on the side here. So you can just launch it and it's sticky in the viewport, right? It's just always there, which is great. Or you can always hit N and hide it. So it's just another toolbar. So let's import a CAD file. We have import and export up here. We've also got a bunch of actions here that you can run on your 3D models to do different kinds of processing. And we'll dive into that in a bit. But first, you need an actual asset to work with. So I'm going to go ahead and import a CAD file. Go to my demo files here. And I'm going to grab, say, let's do this door. Door is a small file. It'll load fast. And we've got a bunch of options right here in the import bar. You can choose whether you're importing a CAD file, and you've got CAD specific options. And you've also got 3D options, which is specific to 3D files. For example, FBX has an option to flip the neural maps so that the Y channel or the green channel comes in correctly. And also we have some options for USD and discarding things that you don't want. But for CAD files, the first option that you have is basically how much resolution do I want to apply to the model. And by default, you probably find it's a good resolution, but you can choose different resolutions from these presets. And we also have a custom option, which basically uses these three parameters here. And maybe I should pull up maybe the slides. That'll help a bit more so we can kind of see how that is. You have these 5 preset options that kind of get you there. We've pre-configured these to come up with different resolutions that work. And you can choose a low resolution if you want, but it's usually better to pull in a fine resolution and then use our decimator to do a curved-based reduction. And we can talk about that. It'll give you a better result in the end than just choosing coarse and starting from there. It's generally better to work with more data than to work with less. And then for custom tessellation, you have basically these 3 green controls. If you want to dive in and do a bit more customization for how much resolution to turn from the CAD surface, which is a blue parametric, infinitely curved surface, basically, into a tessellated mesh, which is triangles. And you need the triangles in order to do UVs and assign materials and do rendering and make it a portable asset. How fine of a resolution you tessellate to is something that you can control in a really fine and easy way. By default, fine is great for most purposes. I generally like to pull in the highest resolution that I can and then decimate from that because I get really good results. So we're just going to pull in the door here and I'll show you how that works. And there it is. And we'll hit the home key to get zoom in. And by default, it's laying flat on the floor. And that's probably not what we want. So there's an option here to import. And basically you can say, hey, if things are flat, you can convert from Z to Y up. So Blender itself is Z up, right? It's red, green, and blue. So red is the X-axis, green is the Y-axis, and then blue for Z. So it's a Z up translation. So that model was modeled with a Y up orientation in the CAD software. And basically this will convert between those two to get it in. The other thing we have here is CAD sewing tolerance. And what this does is it will, by default, it's got a value of 0.05. And so it's going to sew together the different patches that make up the CAD surface. So let's turn that off and see what happens when we don't use that, because that's a key feature. I'll show you why that's important. So again, we imported with Z to Y up so we can see. It doesn't, another cool feature here is that it's non-destructive. It keeps around old surfaces in your file. So if you want, you can always go back to these other surfaces or hide them and work with them however you want. I'm just going to delete it just to show this guy. But without the CAD sewing tolerance, you'll see that it has all these separate patches. And this is typically how a CAD file is made, is built of these separate boundary representation surfaces. In order to generate all this fine curvature, you need all these separate surfaces. So without sewing, you get all these different parts, which may be what you want, but in general, as a 3D artist, I want all this stuff taken care of so I don't have to deal with all these little parts and then have to patch them together. The other thing too here is if we turn on geometry here, we'll see that some of these patches are super high resolution and some are super low resolution. And it really depends on the surface itself and how it was made, how it's going to actually be tessellated. And so because these are all separate, they're all tessellated to a different resolution, and you end up with these kind of differences in the way that they're tessellated. And sewing basically automatically takes care of that. So you don't end up with these really strange kind of, get back to that corner. Yeah, strange kind of differences in resolution, which make it hard to work with these things because they're really different and you'll get little gaps in between things. So if we can zoom in tight there, we'll see that this thing only has these really long, thin faces. And there are actually gaps between this surface and this because they're not matching up in their vertices. So let's re-import that and we'll turn on those options we talked about and see how that works. So here's the door trim. I'm going to keep it at fine. We're going to keep the CAD sewing tolerance on so it sews those patches together. The other thing we can turn on is removing T-junctions, which is where those little patches were coming together and they had different resolution. This will attempt to solve that so that we don't have gaps in the model. We're going to convert Z to Y up so it's facing up. And then we'll talk about winding order in a little bit. You can also fix things that are inverted, for example, faces that are facing the wrong way because they were negatively scaled in the CAD app or however it was. You get inside out surfaces really easily and that kind of fixes it. And then remove occluded parts will automatically remove things that are inside the model that are invisible surfaces. And you can do this on import, or you can do it later as an action. We have actions here for basically handling that. And then simplify mesh basically sets an upper limit for how many triangles to allow from the import. So if you have a really complex model, let's say a whole building or a highway or some crazy, geometry, and you don't want it to come in as say 100 million triangles because it will just cause Blender to slow way down. You can set an upper limit and it'll basically decimate the model down to hit this limit. So right now, by default, it's set to 10 million. Is that right? Is that enough zeros? 1, 2, 3, 4, 5, 6. Yeah, that's 10 million. So that's the upper limit right now, which is pretty good. It's a fine limit. And if it doesn't have to simplify it, if it gets in below 10 million, then it won't do any decimation at all. And then you have the custom options. So we chose fine. We have the sewing on, so it sews the patches. We're going to remove T-junctions and we're going to make it facing up. So here it comes in. It's pretty fast because this model's pretty small. And look, right away, it solved those issues with those surfaces. And now we don't have any gaps between things. They all have the same number of triangles. But we have nice curvature still. It's definitely a decent resolution to have on the model. And we don't have all those problems. The other thing is that it will sew these patches together depending on material. So this model had just one material for the whole door, but say if it had a different material for the gasket around the window, then that would be one surface and the metal part of the door would be another surface. So that's kind of how those options work. Let's look at a more complex model like the car. If we import the CAD model for the car, that car is actually It is 400 megabytes. So I know that this thing takes about a minute and a half to import. I'm just going to show you the one that's already imported so you don't have to wait. But basically, once you import it, let's see, let's go to custom car. This is what you get after you import it. And basically, one of the problems here is that some of the surfaces are inverted. And you can do this by turn on backface culling. By default, backface culling is off. Excuse me. So when you pull in a CAD model and it has flipped surfaces, you won't be able to see that because by default, culling isn't on. But it's good to turn on culling so you can see these kind of problems and fix them up front. Another way to look for this is if you turn off backface culling and you go here in viewport overlays and you turn on face orientation, it'll render in red any surfaces that are flipped or inverted. So that's another kind of handy way to see when surfaces are facing the wrong way. And why is that important? Why do I need to flip these things? We go back here to the slides, I can kind of show you. This is with the flip surfaces, right? And you can see things that are inverted. If you try to render surfaces as just two-sided and just say, hey, I don't care whether they're flipped or not, some shaders are going to have problems with that because it considers the surface to be facing inwards. And then it's going to have trouble trying to figure out how do I use a normal map on this, or how do I use anisotropy, or anything that is view dependent or angle dependent in the shader. It's going to have problems kind of processing that. And additionally, when you go out to real time, typically those are single-sided and things are going to look inside out in a real-time viewer. The other problem you get too is that when you try to bake an ambient occlusion texture, which is really needed for kind of PBR shading and to get that fine shading detail in a real-time renderer, the surfaces that are facing inwards are flipped inside out. And so they're going to render black because it's going to think, oh, that's totally occluded. So you really do need to flip these surfaces. And it's really pretty fast to do this here in the tool. It's basically on import. Let's just go ahead and import the whole thing. And I'll show you how that works so we can talk through it. But I'm going to just delete all these guys. And let's go and import that file. Let's see, it's my demo assets. There's the car. It's 400 megabytes. We're going to sew. We don't need to do any of that. We're going to fix the winding order. Let's import that file. And basically, it's going to go and run to the background and import this file and do that tessellation for the winding order. And basically what it does is it looks at each patch and tries to figure out which way is that patch facing. And it basically shoots rays at the model and tries to figure out an overhaul basis. Should I connect all these connected triangles? Should I flip them or not? You can also do it on a per triangle basis, for example. Some of our operations like occlusion, when you're removing hidden parts, say you have an engine inside the car and you want to remove the engine because it's just extra triangles that are not used in your render. You can remove that based on a per triangle basis and remove every triangle that's not seen, or you can remove it on a whole part basis. And generally, as a 3D artist, I don't want to keep extra little triangles floating around, even if through a gap in the hood, I can see individual triangles of the engine. I'd rather just strip out the whole engine and not have it there. So that's the default, is that it'll pull out those parts that are whole, all the connected triangles, rather than doing on a per triangle basis. But you can get in there and you can choose that as an option if that's something that you want to do. So it looks like it's just about finished here. It is about a minute and a half to pull in that 400 megabyte file. And it has solved that. There are no red faces here for face orientation. If we go back to the viewport shading, turn on backface culling, all those surfaces are now facing the right direction. So that's a really cool feature to have, is the ability to fix winding order automatically, because it's pretty hard to do that manually. Something else, we talked about occlusion culling. That's pretty cool. Well, let's see if we have a slide for that. Yeah. So here's a drill, for example, and this drill has all these internal parts here in red. It has little screws and has engine parts and things that you can't see from the outside. We can automatically kind of strip those out just with one button press. The trouble gets in when you have a model like this, for example, where say if the glass was transparent, you'd be able to see what's inside the model. So if we go to wireframe here, you can kind of see there's a whole interior here with seats and a steering wheel and controls and all that. If we go in, since this is a CAD file, it doesn't have that many materials, but if we go in and actually just quickly make a new material, and we're going to call this, let's see, we're going to call this glass. And we're going to, let's see, give it some transparency here. And we're going to choose this and change it over to glass. Okay, so now we have glass on the front. Let's do that for the other surfaces too, for where it should have glass. And what this does is basically, yeah, it's still polygon surfaces that are on the model, but since they have an alpha value, our occluder can be aware of that. And by default, it's aware that, hey, even though the seats are occluded by the glass, since they're transparent, they probably shouldn't be occluded. They shouldn't be stripped out because you can see them through the glass. And you have the option to do that how you want. So here's the remove occluded parts action. And we can run this, but you can choose how thorough you want the culling to do, fast, thorough, or extreme. Just the default's usually fine. You can check the visibility per mesh or across the whole model. Now, by default, I want to consider the whole model together. But if you had, say, a door that was all one mesh and had internal parts inside the door, but you only want to remove the inside parts of the door and not the rest of the things inside the model, you can do that. That's kind of what per mesh does. It looks at each individual mesh and decides what are interior parts only that are occluded by the mesh node itself. So by default, we just turn that off because I want to do the whole model. And then ignore transparency is that one that would say, hey, I don't care about the glass, remove everything that's inside. So let's just do it without that, the default, and say occlude everything that's invisible. First, I'm going to turn on statistics so I can see how many triangles total in my model. I've got about 1.2 million, right? 1.194 million triangles before I run this occlusion culling. And let's see how much it strips out. And basically it makes a copy of each part, right? It does the export out to the runtime running in the background. It does all the culling and then pulls back in that model. And since it's non-destructive, you have all the original surface before. So for example, here's the processed model. It's just above 1 million. So before we hide this guy and unhide the other one, 1.194, right? Basically 1.2 million. And after that, the original imported model, and now we're down to just above 1 million, 1.1 million. So that's good. It got rid of what, about 100K faces automatically without changing anything in the model visually, right? We can still see all the interior parts there. But what if we wanted to just kill the inside and say we had the glass? What if we set the glass to maybe it's a solid and it's a dark color, right? It's just tinted glass or whatever. I just don't care about the interior and make this shiny glass, whatever. And I can't see the interior, right? So let's strip all those parts out now. So if we say ignore transparency and run it, now it's going to think that these are opaque and basically do the culling of all the parts that you can't see inside the model. And so that's just another way to really simplify a model so that you get something that's really efficient, that renders fast, and also exports fast and makes a real-time file that works well. So there you go. It stripped all the interior parts that are not sticking out to the outside. And then you can go in and just make this material to be a totally opaque surface. and who's the wiser, right? It's a great way to make a really lightweight model. So that was that. Let's see, what else do we have in our slides that we wanted to talk about? Let's go back to our summary here. So we talked about tessellation, the different resolutions when you import. We talked about sewing patches on the door, right? All those different parts. Z to Y up. Winding order was flipping those faces on the car, and other models have it too. And then occlusion culling, we did that. And oh, decimation and baking. So let's talk about that some. So now we have this model, and since we culled out the interior, we're down to 784K, which is pretty good. But for a real-time model, that's going to make a fairly large file, and it's going to take a bit to render in a web engine. You generally want the asset to be, say, under 10 megabytes or so to be really efficient and for it to download fast on someone's phone and that kind of thing. So we have a bunch of decimation options. Decimate and Bake Atlas is a great one because it'll keep all the existing materials that you have on your surface, and it'll bake occlusion maps and that kind of thing. So we can bake occlusion map to get that fine shading detail. You can choose your resolution that you want the texture to be overall. I'm just going to leave it at 4K. We've got another cool thing that's called texture resolution auto scaling. So basically it will automatically scale textures for different parts based on how much resolution the overall mesh takes relative to the other surfaces. So you can get smaller texture files. They don't all have to be 4K renders. And then the decimation target, let's go down to 50K for this car. So it's 50,000 triangles instead of 784. Deviation just gives you curve-based decimation. So it looks at the overall curvature of different surfaces. And if it can go lower than 50K, it will, based on this kind of a quality metric. It's a quality-based tessellation or decimation target. You can also do a size on screen target. So for example, I know IKEA has a standard where they set things to a resolution dependent upon how big it's going to be when it renders on the customer's screen. For example, if you have a representation of a car that's a real-time model and you're displaying it on a car LCD inside the car, then that resolution of that screen is going to be fairly small, and you can tessellate or decimate based on that resolution. But it's also a way to do LODs really nicely. You can preserve tile textures. How do you create the new UV that you bake the ambient occlusion into? We're just going to say, hey, let's make a single atlas for the whole model. So we're going to combine the whole model into one part and make one texture set for it. And we're going to combine all the merges, all the meshes together and all the materials together into one asset. So instead of having 300 objects, we're going to end up with one object that's going to be all merged together. And it does it all automatically. You just choose these options and run it, and it does all that work for you, which is really handy, right? It does all the merging of the parts. It creates the new Atlas UV for it all. It does the unwrapping and then bakes the ambient occlusion for it and does it all automatically, and does then the decimation on top of that to take it down to 50K, which is super efficient. And then we'll export it out to a real-time file and load it up in the sample viewer or one of the GLTF renders. 3JS has a great one, or Babylon.js has a sandbox you can load things in. I forgot to say that you should ask questions anytime you have them. And if we have Q&A, we can go over some of those things. So if you have any questions, definitely hit the more bar and go to the Q&A and ask some questions. Happy to do any other kinds of explanation of how things work. Okay, so it's finished up, and it's basically, it has kept the old versions of the file that were in here before we did any processing, and it's made a new copy, and it's a single mesh now, and it's under 50K triangles, and it's got one material, and it's gone ahead and baked it all. So let's go ahead and export this out. So when we export, we have a bunch of options here to choose. SDZ if you're going out to a Mac or iOS device, USD, so you can go out to USD, which is a really great format for interchange between different applications, and it's being used more and more. And then we have some other options, OBJ, et cetera. I'm going to choose GLB because it's a self-contained file and it's really easy to view on the web. So once we do that, we can then, I'm going to go out to my demo assets here. I'm just going to leave it the same name. And in the options here, we've got some great options. So you can go ahead and do, say, Draco mesh compression, which does a really good job of making an even smaller file. You can go Draco lossy, which adds even more, and mesh quantization, which is another GLTF option to do basically use less bits, less information for the vertices. That's an easy way to do mesh compression. You can also do various texture format compressions. So I'm going to choose WebP because I really like that format. It makes a really small texture without adding too much noise. But you can do 8-bit PNGs, so you can go out to a grayscale PNG, for example, or a 16-bit PNG, which is 16 bits per channel. So it's 65,000 levels of red and 65,000 levels of green, etc. And that makes a really high res file, but it's going to be large. So if you're doing interchange between different applications and you're not really going out to real time, then that's probably a good result. We also support KTX, which is a great compression format, which basically keeps the textures compressed when they're uploaded to the GPU, which is really cool if you're doing like a configurator where you're loading and unloading meshes constantly. This makes it much faster in terms of loading those up to the GPU to render in real time. So I'd recommend using KTX if you're doing a configurator or anything where you have a whole bunch of assets in a scene, for example, and you're doing, say, room configurator with a bunch of objects in your room. Or JPEG and PNG are the default. So auto basically says if there's alpha needed in the texture, it'll use PNG, but everything else will use a JPEG. So I'm going to choose WebP because I like WebP. And then for a neural map, you get separate controls. So you can choose if I want to keep my neural maps to be, say, lossy or lossless, for example, you can choose PNG. Then you can downsize the textures here on export. You can separate the occlusion out so it's a separate texture from the metal and the roughness texture, or you can just leave it packed in together. And then you can exclude material extensions. So for example, you can remove, say, transmission and volume and IOR and extra things that you probably don't want in the model. You can remove them there. We've got some other options, but I'm just going to go ahead and export it straight out. Well, excuse me, and take a sip of water before I get totally coarse from talking nonstop. Okay, so it finished. So now let's go to a web browser and load up, say, the sample viewer. And I'm going to go find my model. Let's see. Let's go to my demo assets. And there it is. It's 7.5 megabytes, so it's under 10 megabytes, which is great. And let's pull up the web browser here and load it in. Take a look. And there it is. Okay, so now we can see it's got the ambient occlusion on the model, so it's got all that fine kind of shading detail. And we stripped out all the interior parts. So let's see, can we zoom inside? Yeah, we can see it's pulled out all those interior bits that we don't need because we set the glass as being opaque. And it's done a pretty good job. We've still got some artifacts here. So we can go in and do even more kind of occlusion on these little parts that are hidden inside this model and be more aggressive there. So let's do that. Let's go back to Blender here and let's hide this processed model, right? That was the one we worked on. Let's get back to the one that, is this the occluded one? I think it is. Let's see, let's go back to the glass here. Oh, we need to be in the right render mode. We can see, oh, so this had the interior parts, which is fine. Do we make it the wrong? Yeah, we made that transparent. What happened here? I kind of got lost. Let's go back to the original file and just get rid of these processed bits. So let's do this one. And this is back to the 1.2 original. And let's do some occlusion mat culling. So let's be more aggressive here, our occlusion. So that's what the part in the visibility threshold does, is you can get more aggressive here. So if I say 0.4, that's going to say if anything's 0.4% visible behind other things, then still cull it. And so we'll be able to remove the interior parts here inside these things. So there are some other parts in here that maybe it wasn't culling before because it was being conservative. So let's go ahead and run that. We're going to ignore transparency and remove all the parts inside. Oh, excuse me. Run that again at C, going from 1.2 million triangles, and see what result we get out of that. Okay, so it finished it and it got us down to 670K. That's pretty nice, actually. We've still got glass here, right? Yeah, we've got glass. We go to material. Here's our glass. If we set that to opaque, right? What I do here? Is this the right surface? I might be on the wrong model here, or Blender is giving me some grief. Yeah, I'm not seeing it. Why did it do that? I must be doing something wrong. I'm a Blender noob. I'm not that efficient at modeling stuff in Blender. But let's look at another model. Let's try another model that might show us some other occlusion stuff. So let's import, and we'll choose maybe the drill. Drill's a good one. So the drill, I know, is going to need Z to Y up. I'm going to let it go ahead and sew the patches, and I'm going to import it. I had a couple questions that were answered already. So how do I fix models with really dense triangle counts? Teresa helped out with that. We got a bunch of decimation stuff. And what kind of UV tools are available? That was a good question. We have a whole bunch of automated UV generation things, which are great. You can create tiling UVs in real world scale, which is really great. So you can say basically it's in 1 meter is the size of the UV. You can say, hey, I want it to be in inches, which would be out of a meter, that'd be 0.0254 would be the resolution for that. So if you love imperial units, you can do 1 inch UVs, or you can do 1 centimeter, right? It'd just be 0.01. So that's a great way to do that. You can also basically take multiple materials and pack them together so that they keep the same UV layouts, but become much like UDIMs, basically, where it's things that are packed together. Or you can generate UV atlases. So it's really easy to do. So here we've imported this model. This is a CAD asset. It's been tessellated. Let's look at the geometry here. And if we look at it with X-ray on, we should be able to see there's some interior parts here. So there's this wire in here, and there are all these little screws and stuff that are they're hidden inside the model. You can't see them from the outside. So we really should cull those, but there are some interior parts that can be seen from the outside that you don't want to cull. So it still needs to be smart and not cull away these parts that are semi-visible from the outside, but not wholly visible. So that's where the culling amount comes in. So let's look at that. If we look at the original surface here with nothing selected, is 646 objects at 163K. So let's go ahead and take it down to say, I don't know, it's 163 now. Let's do 60K, for example. Deviation, size on screen, I'm not going to use. I'm just going to go ahead and do that. So this is decimation. I want to do occlusion. Let's make sure I'm using the right thing here. Remove occluded parts. There's no transparency here, so I don't need to worry about that. So with the part visibility threshold set to 0.1, that's kind of the default, right? That's a pretty conservative amount. And we'll see what happens when we run just with that. From 646 and 163K, it's now down to 466 and 113K triangles. But I bet there are still some parts here inside the model that maybe could have been called away but weren't. Yeah, so here, there's like a battery or something in here that was left behind because it's partially visible through a crack in the model, but not totally invisible. But who can really see that from the outside? It's pretty hard to see that thing unless you're in a particular angle and you're one ray cast and you can see that thing. Otherwise, it's just not that visible. Oh, and it left another part too, this other rectangular thing, this frame, because it thinks that it's partially visible. So that's just it being really conservative, right? So let's hide the processed model, unhide the original that has all those parts inside of it. And this time, let's be more aggressive. Let's say 40% and run it. And then I think it'll pull all those parts out. And it does a pretty fast job. So now it's gone ahead and pulled both of those things out, right? There's not that cylinder and there's not that frame. The other thing that's option here too as well is if we look at the original here, we can just cull the small parts. So we have all these little screws here, which are really hidden inside the model. You can't really see them from the outside, but they are there, right? In X-ray, you can really see them. But say you just want to cull away the small parts, that's easy as well. There's a remove small part function, and it basically looks at anything in scene units, which generally is 1 meter. So here it's saying anything that's smaller than 1 centimeter, go ahead and remove it. And I'm going to choose maybe 2 centimeters because some of these screws are a little bit longer. So I'm going to set this to 0.02. I'm going to go ahead and run it. The other cool thing about the Blender interface is that it basically runs on whatever's visible or whatever's selected. So right now I've got a bunch of things that are hidden, previous things that I worked on, and it doesn't work on those. It only works on what's visible in the interface, which is a really nice way to work, really easy. So it finished it, but it looks like it only pulled some of those, right? It pulled one guy here and a couple other small ones. So these must be a little bit larger than, say, 2 centimeters. So let's choose, say, 4 centimeters, for example, and run it. Excuse me. And again, it's a very iterative process here. If I don't like what it did, it actually pulled out a larger piece that I didn't want it to remove. So I could basically go ahead and redo this work very easily by just hiding or deleting the parts that I don't want, getting back to the original without having to re-import it all. So let's choose, say, 3 centimeters. That might be a better value to choose. Then we can iteratively get back to what was the right value to cull away those small parts. Generally, it's pretty good. It does what we wanted. It is pulling out some of the other pieces. So we probably want to get even more fine-grained here and choose something that does work better. So maybe 0.025, for example, and run that. I'm just experimenting here. I don't even know what's the right value. So it'll take a little bit of back and forth. But basically that's how that you can do small parts only or occluded parts only. Some of the other cool functions we have too are basically removing holes from models. So if you have screw holes in a model, so let's pull open something that has a bunch of screw holes, and I can kind of show you how that works. We have this asset. Oh yeah, here it is. So this is a robot dog asset that it's a very complex model, 2,000 parts, 5 million triangles, and it's got all these screw holes. There's an interior surface inside of here. Turn on geometry. we can see there's all this extra detail inside those surfaces. And it basically will cull all those out because it sees that this is a perfectly round hole with an entry and an exit. So you can say, how big do I want this to be in millimeters before it removes it? And I think this thing is maybe a centimeter across. Maybe it's a little bit less. It might be like 0.1, 10 millimeters. Maybe let's try 20 millimeters, for example. Oh, is that right? Yeah, that's in millimeters. So 20 millimeters. Let's try that. And since we have only this thing selected, it's only going to run on the selected mesh, which is cool. Kind of lets you choose different things for different surfaces. And maybe 20 is not enough. Let's try 40 millimeters. It's going to go ahead and work on a selected surface. Maybe it's more. Let's try 100 millimeters. Oh, maybe I'm using the wrong values here. Is it? Huh, I'm doing it wrong, that's for sure. Me being a noob and not knowing what I'm doing. But basically, it goes ahead and removes these surfaces that you don't need. We also have a fill surface holes, which looks at surfaces that are totally flat, that are like one-sided, and have a hole or a break in the continuity. We can also automatically fill those. So there's all those kinds of features too. Let's see how we're doing for time. We got about 10 minutes left. I'm trying to think if there are other things that we wanted to talk about. We talked about decimation and baking. We talked about exporting to web-ready formats. Oh yeah, so another cool thing here is that when you're exporting out to say USDZ, for example, it doesn't have the complex kind of material handling that GLTF has. So you can't do glass, for example. It has to be alpha blending. And RapidPipeline automatically handles that. So it'll export the right format for the materials based on the format. Let's see what else. We had some other things here, I think, in the slides. Talked about occluded parts. Oh yeah, so normal computation. So you can recompute the normals on a surface based on the surface curvature. And you have a couple different options here. By default, it chooses area, which you might know as face-weighted normals, which basically takes these small bevels and does all the smoothing across those, and the flat areas stay flat, which is really cool. So you get really fine-grained kind of shading. But if you have a more organic model, you probably want to do it based on the angle, which smooths the curvature across all the angles. And you have a fine grain of control for that. So area generally works well for mechanical models, and angle works really well for kind of more biological or curved surfaces. Oh yeah, and the new surfaces, the new features. So one thing we have is a quadrify option. So by default, most of our operations work on triangles, but you can convert those into quads. I can kind of show you some examples of that. If we go back to Blender, I'll pull up an example here, what the quads look like. And let's see, more assets. Let's see. Oh yeah, the tea kettles are a good example. So here I pre-converted this into quads, and based on the tessellations of the surfaces, it'll convert into quad meshes on export to USD. And so currently that's the feature, is that you can convert to quads on export out to USD. And then these USDs are re-imported here into Blender to look at them. But basically you're still limited in terms of if you have quad patches that are, or if you have surface patches that are differing resolutions, it still has to figure out, how do I convert from this resolution to that resolution? And here it's chosen basically from this resolution is lower, then this is higher. It's still created quads, but they're limited to the different resolution going from here to there. But it still tries to be really smart about that. It tries to still give you good loops, but it really depends upon the surface, the differences in surface resolutions across the model. So these are based on different resolutions of the tessellated input from the CAD model. You can see it gets a really fine resolution there as well. But again, you're limited to if you're going from one surface to another, it's going to have different resolution in the tessellation. So let's see what else. We talked about quads. Here's the hole filling, and what it does, it basically replaces the interior surface with these kind of triangle fans. And then that becomes really easy to do the decimation of, because it's all seen as a totally flat surface. So you can get this down to a really low resolution, which is nice. And then the surface filling, based on if it doesn't have an interior surface, if it's just a hole in the mesh, we can also replace that with a solid mesh. And a cool thing about it is that it interpolates the UVs from the surface to the hole itself. So now the hole has the same UV, continuous UV with the rest of the surface. And you can also interpolate the material values so it would use the same material as the rest. But it's up to you. You can choose to have a different material on the hole or not, or having them be separate objects and not be integrated into the main surface. So that was it, I think, on Q&A. We solved all the questions, unless anybody has any more questions. The other thing I wanted to mention is that when you go to our website, there's this chat button, and basically that goes directly to a human person. We don't use an AI chat bot or anything. So when you ask a question on the website, that goes directly to people, and people will answer it, including me and the other technical artists on the team. And so you get actual human responses, which is super valuable and just saves you time, right? We get right to the heart of the matter and try to solve the issue for you, whatever it is. So that's another great feature. If we go to a web thing, let's pull that up and I'll just show you how that looks. So here's RapidPipeline. And when you log in, you get this interface here for downloading of different integrations, how our different tools work. So you've got Twin Studio, which is the newest one. You've got our plugins for Blender and Maya, Max, Substance, and Unreal. And then there's also a command line interface. So if you really want to optimize the processing of a huge number of assets, then that's the best way to go, the CLI, because it really lets you grind through hundreds of thousands of assets. But as well, we also have this cloud interface where you can use it even without a 3D application. You can load up 3D models and you can look at them directly in the UI and do all kinds of processing on them and inspect them and see how they're made and bake ambient occlusion and do all the things that you can do in Blender. But here it's in the web UI. So that's another option too for people if they want to do that. And that's kind of the RapidPipeline interface and the chat button, which is underneath here, my Zoom thing, that goes directly to a person. So the people will answer this, which is great. So I think that's basically it. If we don't have any other questions, I'm going to go ahead and wrap it up here. Thanks for joining. I really appreciate having your eyeballs on the scene, and I appreciate your questions. That was great. We are recording this, so we'll put this up on YouTube in a bit. In case you missed it, or in case you missed the start, or you want to share it with somebody, feel free. And if you have any questions or anything that pop up later, then just hit the chat button and we'll try to do our best. Anyway, thanks again for coming. Oh, we got one last question squeezing in there. Let's see. Oh, thank you, Eric. Ah, awesome. Yeah, you're welcome. Anytime. All right, take care.